about atomic structure, and it also tests your ability to apply some of your maths skills, specifically talking about percentages. So the first one below, the diagram shows two isotopes of neon. So we should know isotopes are the same elements, which means they have the same number of protons, and they are heavier or lighter versions, so different number of neutrons. Same atomic number, different mass numbers. So it says, compare the number of subatomic particles in an atom of neon 20 and an atom of neon 21. Okay, so the first thing we're going to say, subatomic particles, what does that term mean? It just means particles that are smaller than an atom, so neutrons, protons and electrons, the things that make up an atom. So we want to compare the number of protons, neutrons and electrons. So the bottom number here, the atomic number. In physics, we're more interested in what's happening in the nucleus, so we call that the number of protons. In chemistry, you'll probably learn it's the number of electrons, because chemists are more interested in electrons in terms of explaining chemical reactions. So they both have 10 electrons and 10 protons. So compare means say if they're the same or say if they're different. So both have 10 protons and 10 electrons. Okay, and then neutrons. So this top number is the mass number. So the two subatomic particles that have mass are neutrons and protons. This tells you the total number of neutrons and protons. So to get the number of neutrons, we have to do a subtraction. So neon 20 has 20 minus 10 equals 10 neutrons. Neon 21 has 21 minus 10 equals 11 neutrons. You needed both those points to get the second mark. It's worth pointing out as well when you're dealing with radioactivity questions, sometimes, particularly in half-life questions, it gives you something like this and people get really confused by that 21 at the end and they start trying to do something with that in their calculations. When it's got the dash between the name of the element and this number, that is just part of the name. This is telling us that this is a slightly heavier version of neon. This is a slightly lighter version of neon. So you don't do calculations with those unless it asks you what's the mass number, what's the number of neutrons and so on. Now part B is a pretty unpleasant question really, pretty difficult in terms of maths, but they do throw these in now. There are some that are just applying maths skills to something new. So there are 18 neon atoms in every million particles of air. So we're thinking about proportion, fraction, percentage. Of these 18 neon atoms, 0.27% are neon 21 atoms. So it tells us the proportion of air particles that are neon and the proportion of those particles. The key word here is of. You might remember from maths that means we times things together. So calculate the percentage of particles in the air that are neon 21. So the first thing I'm going to do is find the percentage that are neon. So 18 in a million. So that means I'm going to do 18 divided by 1 million. And I'm going to put that in brackets. And that's going to give me a decimal. To turn it into a percentage, I times it by 100, and that gives me 0.0018. Okay, percent. Okay, and then we want to find the percentage of those that are neon 21. Okay, so that 0.27, that's a percentage, so we need to turn that into a decimal, so we divide it by 100. So 0.27 divided by 100 okay, so that's as a decimal, okay, and we're calculating a percentage. So this is the percentage of neon atoms in the air, this is the proportion or fraction of that percentage that is neon 21. So we're going to do multiplication. And that's a percentage, so the answer I get is going to be a percentage. And that is 4.86 times 10, don't know why I've done that as a capital, to the minus 6. And that is already a percentage because I found a fraction of a percentage. If you want to give that as a decimal, it's absolutely fine. Okay, but you don't. It's still a percentage as a decimal rather than in standard form. Okay, we now have the image below shows a sign containing neon connected to an electrical supply. The neon atoms gain energy when the sign is switched on. Explain why the sign glows when the electrical supply is switched on. So this is a question about electron energy levels. This is the main application. If a question's about that, it's either going to be about something glowing or it's going to be mentioning the word electron levels and giving you a diagram of them. So energy levels are just the idea that electrons cannot be any distance from the nucleus. They have to be at specific distances from the nucleus. And what distances they are depend on which element you've got. Okay, so the first thing, they're electron energy levels, so you've got to mention the word electrons. Okay, and electrical supplies, we think about the purpose of them. They give the electrons energy. So I'm not going to write out an answer to this one because I want you to listen and then actually have a go at constructing a written answer yourself. So that's the first point, is electrons gain energy. Okay, and that means they are going to change their energy level. They're going to go up to a higher energy level. Okay, when they're in higher energy levels, okay, they have all this excess energy and they want to lose it. So they then drop back to a lower level and they release energy. Okay, but the energy that they release is in the visible region of the spectrum. So it's visible light. So when I say visible region of the spectrum, I mean the bit in the middle of the electromagnetic spectrum that you learned about when you did paper 2. So you've got long wave, radio, microwave, infrared, and then you've got visible light, and then your ultraviolet X-rays, gamma rays. So when they drop, the gap between the higher energy level and the energy level it drops back down to means that neon specifically will give out visible light.